The seventh problem of semifinal 1 of the 2006 MIT integration B, the indefinite integral of sine of the natural logarithm of x. This is actually a fairly very easy problem. I would approach it from just substituting, but we could just go the hard way without substituting for log x. But my choice is substitute for log x. So let's see how we may be able to solve. So for our problem here, as I said, we would want to substitute for the natural logarithm of x. So we'll just say let u be equal to that. And that means that du dx is the same as 1 over x. Multiply both sides by x and also dx. So we have x du equals to dx. And from here, we can see that e to the u equals to x. So that can be appended there. So we have e to the u du being something that we can use substitute for dx. And so our problem, the sine of the natural logarithm of x can be now transformed into the u domain as sine of u times e to the u as our integrand in the u domain. And so we can go and use integration by parts. First, we would like to express sine u as the derivative of negative cosine u. And we know that integration by parts lets us look at a problem if we have a product of two functions, v and the derivative of capital U, then that integral becomes the product of u and v minus u times the derivative of v. So here we take our negative cosine u as the capital U, so that the product uv now becomes a negative e to the u cosine u plus, because this negative interacts with this negative here, we have plus e to the u being the derivative of e to the u times cosine u, which is our u here. So we can now go and do another nested integration by parts. Express cosine u as the derivative of sine u. So we have eu times the derivative of sine u. And so if we go ahead and do the same procedure, the product of uv, since in this instance we have u as sine of u, the product of u and v will be e to the u times sine u minus the derivative of vu is e to the u times sine u. And so we can see that this is the same integral that we started with. So here we can use I to denote our initial integral and apply I here again. And so we can now bring this I to the left hand side, and we have 2I being equal to e to the u sine u minus e to the u cosine u, such that our integration in the u domain, the integral of e to the u times sine u, is equals to I, which is equals to e to the u sine u minus e to the u cosine u over 2. But we had done substitution initially, so we had said that let u be equal to the natural logarithm of x. So our initial integral in the x domain now becomes the integral of sine of the natural logarithm of x equals, in place of u here, we have e to the log of x sine log of x minus e to the log of x cosine log of x over 2. It's okay to be content with that, but we know what e to the log of x is. E to the natural log of x is simply x. So the problem becomes x sine of log of x minus cos of log of x divided by 2. You could even go further by saying, okay, no, this is the same as x sine of pi over 4 minus log of x over root 2. These are all valid answers. Whatever you choose to go with, that is fine, but they're just expressions of the same thing. And you may wonder why we're able to arrive at this, because what we did was we had our final expression that was x sine of x minus cos of x over 2. We said this could also be expressed as, can pull root 2 out, 1 over root 2 sine x, 1 over root 2 cosine x over 2. This and that interact. So we have x, and this becomes cosine pi over 4 sine x minus sine pi over 4 cosine x over root 2. And this is just the same as x sine of x minus pi over 4 over root 2. So that's how we're quickly able to transform it. But these are just semantics, all the same. If you haven't subscribed to our channel, we do encourage you to subscribe to our channel. We definitely would appreciate your support. Please like our video, share if possible. So until next time, bye bye.